So this is the 2023-2024 exam version number 1 for impulse and conservation of momentum. And so I'm going to just go through these problems. I'm going to make a separate video for different chunks of the exam just so that the videos don't get too long and it's a little bit easier to navigate them. So we're going to start with number 1. A rabbit and a tiny bear are driving massless bumper cars towards each other. The rabbit is going at 10 meters per second and the bear is moving at 35 meters per second before the collision. The bear has a mass of 5 kilograms and the giant rabbit has a mass of 25 kilograms. And after the collision, the bear moves at 2 meters per second. The bar chart to the right shows the momentums of the bear and the rabbit, but are not drawn to scale. What is the momentum of the rabbit before the collision? So I'm going to do this on the bar chart itself because sometimes I feel like that is helpful when you're trying to work on figuring these things out. So the bear is going at 35 meters per second. And remember that momentum is mass times velocity. So the bear before the collision is going to be this one. And so that's the momentum is equal to mass times velocity. So that'd be the mass of the bear, which is 5 kilograms because it's a tiny bear, times its velocity, which is 35. And that'll give you a momentum of 175. And then the momentum of the rabbit in part A is mass of the rabbit times the velocity of the rabbit, which is going to be 25 times 10, which is 250. But this rabbit's going the opposite direction, so that's why it's going to be negative 250. And then it says, what is the momentum of the bear after the collision? So after the collision, my bear was moving at 2 meters per second, and the mass is still 5 kilograms. So that means the momentum of the bear after the collision is 10. So the mass being 5 and velocity being 2. And then all of these, the units for momentum is just like the things that you multiplied together. So the momentum is kilograms, because that's your mass, times velocity, which is meters per second. For part D, you could do the equation several different ways. You could write it with just the letter P for momentum and then use subscripts to notate bear versus rabbit. Or you could do it with numbers. So I'm going to go ahead and write out both ways. So here we have the momentum of the bear plus the momentum of the rabbit at the beginning is going to be equal to the momentum of the bear plus the momentum of the rabbit at the end. And then I went ahead and put in the numbers. You could also do the mass times velocity for each of those momentums and just leave the multiplication in there. That's also totally fine. Any of those options I will accept for full credit. And then it says, how much momentum does the rabbit have after the collision? Well, for that part, the easy part is to just use this equation that you just wrote. And we're going to then solve for the momentum of the rabbit. So then to move the 10 to the other side, because this is really a plus 10, I need to subtract 10 from both sides. And negative 75 minus 10 is going to be negative 85. And that'll be equal to the momentum of my rabbit at the end. And then it says, will the rabbit have positive or negative velocity after the collision? Well, all I need to do here is look right here at my previous question, answer, and because this is a negative momentum, that means that I'm going to have a negative velocity. Let me know if you have any questions.